Hello again. First of all, thanks for all your feedback. I really do read as much of it as I possibly can. For right now, I'm replying to all of the comments, but it's getting to the point where I would have to stay home from work, so can't do that. I realize that sometimes we take a little bit of an amberly way of getting where we're going, and I apologize for that. But it's just a little hobby I'm sharing with you, that's all. Update for you real quick. So the station here, I haven't done anything more on that since the last couple of days. It really does take a long while to get bits and pieces sent over from England, and I've got to save up my pennies too. I really haven't found a solution for the station building. Now, today's video. What I'm intending to do is build on that cheap signal that we made the other day. You don't have to just spend £1. I was just trying to show that you can do things cheaply. So I've got a real signal this time. And real signals don't stay green while the train runs halfway around the room. Ooh, no, not having that. So the project tonight is to try and get a train to start by touching a touch switch that operates a relay that changes a signal. Off goes the train. And then when you let go, the train keeps going and the signal turns back to red, as it would as the train passed it. Mouthful, right? Come on, let's get to the bench. The only thing I've done so far is pull out a few bits and pieces that I think we probably will need. I've got a multimeter in its original cardboard box. I don't know how it survived all these years, but that's where it is. And a soldering iron that's busily brewing. Don't have a cup of tea, so we shall be going quickly, because I need one. Remember the 200 transistors that we got? I'm trying to use a couple of those up. A relay, the pack of, I don't know how many, this is unopened. These are 9-volt relays, and I'll explain why we need that in a minute. One of those little circuit board things, that will be just to solder everything in place later. A couple of bits of breadboard in case I need that. What this is. What is that? Oh, that's the circuit diagram or the instructions for the signals I got. There's two types, and I will show you those first. These are all 3-aspect signals. I bought this one as traffic lights, and you might remember me carving these up. I think this is the last one I've got left. Wasn't impressed with these. They're not traffic lights at all. The red is at the bottom, green is at the top, and I drilled them out and did things with those. So not those. This is what I had. I found these a couple of years ago. I found a pack of 3. I don't remember how much they were. I wasn't really thrilled with them. You see how the lights are on that side of the pole. I wanted them on the other side. I'm picky. Not bad. They were dirt cheap and not prototypical for anything particularly. They looked all right. I used a couple of them. Then, because I anticipated making this video, I really do think about things sometimes, I tried to order some more and found that instead of getting 3 for about $20, something like that, you could get 5 for a little bit less. These worked out, I believe, at $4 a piece. They come in a little box and a zippy. I haven't had this open, but I did. They came in the mail the other day. Let's pull them out. Yeah, slightly. Hang on. Slightly better wired. Still a bit plasticky, but a bit of paint wouldn't go amiss there. But now the lights are stuck in the middle, which is much better. Still got the through the board thing. And now they're black instead of straight plastic. A little bit taller, but these are $4 a piece. You can't beat that with a stick. I like the way these are wired. These you can trim, these you can't. Comes with a resistor already there. So this is what we're going to be using. Now remember, we made one that worked on its own for under $1. and this is $4. This is much nicer looking than the one I made the other day, isn't it? And for all of the critics out there, hush now. I'm just trying to show you how to do some stuff. That's all. We're just having some fun. So this is the signal that it's still cheap. I'm not spending upwards of £30 for a signal. All right, no fancy graphics. Remember, this is a transistor, and I'm just drawing the picture version. We'll show you what one looks like in a minute. And I said something about let's make a touch switch. Well, if you put a little bit of anything in the back end of a transistor, it makes, you remember I said it's a bit like a water main. You let whatever's up here come down through there. I think we can get to touch. I haven't tried this. I genuinely haven't. I think if we touch that, we can probably make it work to some extent. We need a resistor in there. Ooh, I don't know what value. Ooh, we'll think of something. Doesn't matter why. I'll get to that in a minute. We're going to put this into the back end of another transistor. Why are we doing that? Well, because when transistors are taking load, it's complicated. There's always a lot more to it. But basically, you want it to turn on properly or not at all. And if you're just touching this, a little bit of current's going to flow. That will work as a little bit of an amplifier to turn this one on properly. Initially, what we'll do is we'll put an LED in this. Now, LEDs sometimes catch me out. You saw that happen to me the other day. I feel a little bit silly about that. That's an LED. They always look to me like they're in the wrong way up. That's why I get caught out by them. We're going to put a resistor in that. The reason for that resistor is to stop the LED blowing up. Remember that? Now we need a battery to make it all work. We're going to put a 9-volt battery in because I've got one. There we go. I missed the battery, didn't know that. And down here somewhere. Right. Now, this circuit will tell us if I'm onto something. Can I make an LED light by touching that? Then what we're going to do is we'll take the LED and that resistor out, and we'll put in, so that will be gone, and we'll put in a relay instead. Now it's starting to look complicated, isn't it? I'm sorry, it just isn't. And then why are we using a relay? Okay, let me turn my card over. A relay is a coil, whee, like that. And when you put some volts on the coil, whee, passes current, makes a magnet out of it. Basically, magnetism and coils and wires, it's all interrelated. I'm not going to explain it, but you make a magnet switch essentially. So it's a coil that operates a switch. Now we've got a double pole. That's 2 switches. And they change over. So when this thing works, they move over. So let me just draw you a 2-way switch, because I know somebody's going to ask, what are you talking about? So let's say we've got red on that one, red LED on that one, and a green one on this one. What am I doing? I can't even draw a triangle anymore. Green. When the switch moves, it just goes from red to green. So that's one thing that happens. The other, and that of course will change our light. The other thing that's happening at the same time is, if you imagine the break in our rail. Now, where is my piece of test track? Here it is, incoming. So remember our diode across the gap there? It will just join all of that together. So join that to that. So that's what this side of the relay is doing. So clearly that is a whole lot different than that. This is just diode voltages running from our battery, and this is something else entirely. So The purpose of the exercise then is when we touch this, the relay will change, changing the red light to green and joining the gap in the track at the same time. So the locomotive will move from there, whee, down the track. And then as it does, we take our finger off, the light will revert to red and the train will keep going and the circuit is then off. Seriously, there must be 100 ways to do what I'm about to do. Just so you know why we're doing what we do. A couple of things. First, there's a lot of people out there who are terrified of electrics and electronics. This is a simple way to do something that I think is probably manageable, and I'm breaking it down into bite-sized pieces. It's a practical thing, so anybody using DC on their layout can easily throw this circuit in on a insulated dead-end siding or a goods yard or a station. Just a little fun thing. So we haven't built a shuttle circuit yet. I say yet, maybe we'll do it. We'll see if it's popular or not. If it is, we'll do it. If it isn't, we'll run trains. I don't know. So that's what I'm on. I'm not saying this is how you should do it. I'm saying, let's see if it can be done this way. And if you like it, you can do it. And if you've got questions, I genuinely will spend some time responding to your comments. There's one or two obvious electronic wizardry questions in there. There was one the other day. I'll give you an example. 1 second. I'm trying to be quick because I really don't want these videos being half an hour long each time. What they said was, if I were to cut a dead section, so there, and if I were to cut the track there, as metal wheels went by gaps, bonk, they would join the gap together and therefore make whatever were attached to the middle piece, if I'd cut another piece there, flash. So I didn't need a reed switch. A couple of issues with that. Many of the trains I have, all the wheels are metal, so every time a wagon went over it, it would go flash, 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 flash. And it's only the conductor shoe that I want flashing. So that's one thing. So that would be a reason for using reeds. Another issue with that is that even a gap that long, so if you cut again, he said 3 sleepers, I think, it would work on good track, good clean track and good locos, but yeah, I don't like dead sections in track as much as possible, but I'm giving it to you as a viable option. I haven't used it, and I think there are some applications where it would be a fantastic idea. So as it would work in some section or block detection. Somebody's going to ask, 2N3904. Why a 2N3904? Common as muck, cheap as chips. Oh, but there's cheaper ones and better ones. Yeah, but I needed 2 of those for another project, and I bought a box of them. There were 200 in it, so I've got a bunch of them, so that's why I'm using them. Watt resistor, 1K there, I'm guessing, just because I want that to turn on. What here? Well, that will depend on this. We could just use 2 1K resistors. This one's unimportant for now, but at least 200 and, I don't know, 280 ohms or something. Something like that. It doesn't really matter. This one is just limiting the current that LED takes. Once we put the relay in there, I'm hoping I won't blow up the transistor by too much current through a 9-volt relay. I'll show you. If it blows up, we'll have fun together watching the smoke disperse. Okay, these transistors, I've shut the box. They're tiny little things. They have a particular shape to them. Can you see that? It's a bit like a D. And they have 3 wires sticking out the bottom of them. I've drawn one there. The emitter is this side, base and collector. On our circuit diagram, the base is this one. The emitter is the one with the arrow on it, and the collector's the one there with nothing on it. So that's the layout. These things are rated at 40 volts. So 9 volts isn't going to hurt them, and 200 milliamps. I don't think we're going to get to, that's 0.2 of an amp. I don't think we're going to get anywhere near that with that relay, so we should be good. We will see. Now, you might have noticed breadboard. This is how I would usually hook up a circuit like this, but it isn't as obvious if you're not used to this stuff. It isn't as obvious what's going on. So I'm going to just solder it in midair so that we mimic the circuit diagram, just so you see what I'm doing. But typically you just shove these wires in the holes, and you put jumpers in, and it gets all very hairy and complicated, but that's what I would usually use. If you've never used it, it's, again, yeah, it's kind of fun. Get yourself some of that and some jumpers. I don't know where my jumpers are even at the minute. I usually make them up as I go. But there's a mini one over here, a smaller one. And then what I do is transfer it all to a piece of circuit board. Okay, so since we're going to be using this eventually, I just wanted to point out that the color coding on these things can be a little confusing. Red one is for the red LED, yellow is for the yellow LED, and the green is for the green LED. Who knew? But the black one is actually the positive. It's common anode, so that's a little unusual. I see why they've done it, because if you put red there, that would really be confusing. But it's got the resistor in series. Since only one of them is going to be a light at a time, that's fine. So that's what they're up to. So when you see me using this, that's what that's about. Now, you don't need any more soldering lessons. You're good at that by now. But I've just got this transistor clamped in a clip here. I'm just going to solder straight onto there. I've got a resistor down on the board here. And I'll come back to you when I've got the basic circuit together. And we'll see if it works then, won't we? Ooh, this looks like a big old mess. Couldn't find a 280 ohm resistor, so I used a 330 ohm. That's this one here. I'll put my hand behind it so it stays in focus. Still got that transistor clipped in there. The base is sticking out. You see, I touch it, it does work, but it works a whole lot better if I touch both those wires like this. You see that? So when I touch both those wires, it works. Touch switch. Not totally happy with it, but hey, it's working. Now, can I make the relay go clunk when I do that? Let's try. Well, this is what a relay looks like. All kinds of magic writing on the top there. It's a 9-volt relay, which means that the coil that makes the magnet work is 9 volts. This thing's rated at 220 volts, believe it or not. So you could use it for things that would kill you. Let's don't do that. Should be some markings on the bottom. There are. I don't know if you can see that. Let me turn it until you can. There we go. You see those scratch marks in the bottom. I will get a white pencil and see if I can't mark those for you a little better. All right, I've been active with my pencil. Still difficult to see, but there is a drawing of a coil between those two pins. And then there is a drawing of a switch between these two. You see this? So this side is one lot of wires, one lot of the switch, and this is the other. Let me wire that up and see if it works. But we're going to do just the coil first. We'll put a diode across there, and then we'll try the relay, and we should hear it ticking. There's the silver line on the diode. That's the plus end of the diode. So I've hooked up the black end of the battery to the negative end. That diode is across the coil. Do you see the coil symbol there? I've just hooked this up there. So if I hook the plus wire from the battery to this wire, like so, I can hear the relay ticking. Let me put it somewhere you might be able to hear it. Hold on. Now I've put it on the card because I think the card might amplify the sound. Here we go. So I'm just hooking the croc. That's not the clip, it's the relay clicking. So it does work. So now we're going to put that relay into the circuit. So that's what our ugly circuit looks like. Now if I hold on to those two wires there, it is clicking. I'm going to hook up our lights to the circuit here and we'll see if it works. So here's what we've got. A relay is in circuit now. I'll show you a picture of the drawing of the circuit again in a moment. All I'm going to do now is hook up the black wire from the battery to this transistor and we should get a red light. We do. Ooh, genuinely, first time trying. Now, if I hold these two wires here, that relay should energize and that light there should go green. Drum roll, please. Can you see it? Yep, it works. So now the next thing is to hook this up to our track. I will explain it all in just a little bit. Hold on. Now for my next trick, I've cut the diode out of the circuit. So now the train can run in, but because it crosses over the gap, but it can't run out no matter what I do over here with my controller until I join the green and the yellow wires together. Those two wires run off to our relay. Our relay is controlled by a couple of transistors that are controlled by me touching those two pieces of metal at the same time. I'm just going to take the train off the track for a moment, but there's the red light. If I touch those two connections there, where are they? There they are. Can you see at the same time, I wonder? So when I touch these two here, the signal changes. Now that doesn't mean the train will go, it means it can go. Righty-ho, so the train is in the station, the light is red. If I touch these two, it goes green and shorts the little gap using the relay. If I were to turn my controller on in anticipation, train won't move until I touch this. So here we go. That was a bit jumpy. That was me not having the circuit properly connected, but never mind. Back it comes into the station, stops again, reversing the polarity. I will touch the contacts. The light goes green momentarily, just long enough to allow the driver to pass the signal. And then it's red again. And you see the train is still moving. The wheels are still going around there. Do you see that? It didn't work quite as well as I had hoped, but it did work. You've got yourself a touch switch. I'd hoped that I could touch only one leg of the transistor, but it doesn't really work that way. I'll have a look, see why. I haven't cleaned it up and put it on one of these things. I could see no reason for doing that. Other than to show you how a tidy circuit would look, but you've got the idea. So there's the circuit diagram. This mess here, there's the LED and the resistor were just there while we were trying it. The relay is now in circuit. The connections to the relay, very straightforward, but it looks like a mess. I'll draw that for you. Hold on 1 second and I'll draw it on here. So there's the relay circuit diagram. This is the coil of the relay. That thing there in that circuit. This is the red signal. And of course you hook this up to whatever's powering that. I've chosen to use the same circuit power. And I'll draw that on there in just a moment. This goes over to there when you make it work, and that red one goes off, the green one goes on. So when this coil activates, these switches change over. And across the gap, this is supposed to be a piece of track. And across the track is a switch that is operated by that relay. So the only time that gap is joined is when that signal is green. The moment the train passes over it, you let go, it goes back to red. The brake is gone, but the train will continue to move because it's now on the powered side. Well, I'm not going to draw them on there. I'm just going to tell you where they go. So the negative connection goes one side of the battery through the relay and then the other side. So it should be obvious that the wire coming out of there and there goes off to the plus rail. It would just make this a big old mess otherwise. I'm going to leave that static just for a second or two so you can see. Hope you can read my writing. So it's I've used a 1K resistor there, and where you're touching is between the collector and the base. So I will draw that on. One sec. I'm holding the camera with the right hand. There you go. So that's where you're putting your finger. Now, I am quite sure before all the electronics experts come flooding back with better circuit diagrams, I'm sure there's better ways of doing this, but this is a way of doing it with what I had on the bench tonight. The value of the resistor there, anything will do. I've got a 330 ohm resistor. Typically I'd put 220 or 280. I couldn't find either, so I put a 330 and it worked just fine. The only reason for doing that at all was to proof of concept before I put a relay in. Don't forget to put the diode across the relay. Let me draw that on the circuit for you. Now, of course, in a real circuit, I would have drawn it up there. I've drawn it across the relay just to emphasize that that's where it goes. It's to short circuit the back EMF. There you go. In just a few minutes, some down and dirty basic electronics, showing you application as much as anything, giving you a few ideas. Get out there and try it. What's the worst that can happen? I will come up with a proper touch switch for you with some good values. This is all out of my head onto paper. Didn't work the way I expected it to, but we got it working. We'll go from there. Thank you very much for watching. I hope you're enjoying this. You've seen a train run. You have seen a train run. Stop it now. Just stop. I am not turning the layout on tonight. It is really late. I don't know why, but for whatever reason, these down and dirty electronics videos seem to be quite popular. I'm more interested in getting on and making the layout work and using some of these tricks and gimmicks, if you like, in the layout as we go. This is just the how I do what's going on the layout. The next one is a flickering fire, not a firebox flicker. I'll show you that. There's a campsite. Do you remember? Huge bonfire in case I can't make it small enough. But that's what we'll be working on one of these days. Might be quite a long way down the line, pun intended. I've got a station to build, a viaduct or high-level track to sort out, a back scene to sort out now that I've taken the shelf layout away. So plenty of variety coming, but we will get to that flickering fire the next time we do some electronics, or the next time I bounce into not having the materials I need to make a station. Thanks for watching. See you next time.